Hi guys. So having a impromptu stream right here because got some time. It's Chinese New Year now, all the way here in Singapore. So the past few days have been really hectic, but I found some time, 2 hours, and I thought I would use these 2 hours to run through the contents of the part 17 article that we have so that we can use the footage as usual for the part 17 video of our Vampire Survivors series. So as usual, the article is free for everyone until the video comes out. And for part 17, even though previously we wanted to do player stats, right? Player stats, we want to do player stats, but because I started fixing pickup collection for one of our topics on our forums, it just turned out, just ballooned into this entire task. So let's work on fixing the pickup issue that we have on our series first before we move on to bigger and better things. So what is this pickup issue that I'm talking about? If you look at screen over here, you will find that I'm sure that if you've built the game and you've played around with it, you will find that pickup collection sometimes can be wonky. So this was pointed out by sorry, I can't say your name, G Denis on our forums. You can look at the topic right here. So he points this out to us. I tried to fix it on the forum itself, but I realized that the fix was more complex than I initially predicted it would be. So then it became this entire part of our series, right? So what we want to do is by the end of this part, you will go from this is the before, and this is the after. So what we want to do is we want to make the gems and every pickup in the game. So that includes the health potions, and the other thing, we have another item, right? That is also a pickup. Let me just check what the other item is. So just our gem and our health potion, they will both, when you go close to them, it'll track the player character and go to the player character. The other thing that you'll notice is that in our before, right, whenever we go close to an item, the effect is applied immediately and the animation applies after. So for example, in cases where the gem misses you, you notice that the experience increases anyway. So we're going to fix both of these issues. Number one, your gem tracking, making sure the gem tracks the player properly. And number two, we only want to apply the effects of the item, whether it be the gem or the health potion. We want it to only apply after the pickup reaches our character. So part 17 addresses these two parts. So without further ado, let's get started with part 17, right? So the cause of part 17 is actually because of a problem that we have with the player collector script. So if you look at the entire player collector script, just one part of the player collector script causes the issues that we have, and the issue is specifically with the onTriggerEnter2D function. What it does is that it checks whether the game object, so whenever we go close to a pickup, let's say a gem or health potion, onTriggerEnter2D fires anything that goes into its collider. So if you look at all our objects, say our gem, for example, right? Let me just pull the gem out onto the scene. Okay, just checking to make sure that everything is fine. So if we pull out gem on the scene, what you will find is that gem has this collider over here, and then the player collector also has a collider. So if I was to play the game, you will see the collector object of the player has a collider. Just give me some time to load this thing, yeah. So the player object, if I was to pause the game, you will see the player's collector has a radius, and this radius is set by the player stats. So because the player has if you look at the player stats here, because the player has a magnet set of 1.6, the collector has a radius of 1.6. So when this radius touches the collider on the gem, so the gem over here, right, if it collides with the collector radius here, the item will start getting collected by the player. Okay, the effect is instant. So once I move the player within range of the gem, let me just manually move this, alright? So once I move the player within range of the gem, you will see once the game starts playing, the gem will get collected by the player. But the effect will apply before the gem touches the player. So you will see right away the character levels up because he has enough experience to do that. See that? So the moment I play the game, the character levels up because the experience gain is instantaneous. So the experience gain happens first, and then the gem goes to the player. So this is a bit of a problem, right? And anyway, this is caused by the on-trigger enter 2D. So how it works is that whenever a collider touches the pickup, sorry, this is on the player collector, right? So this is actually on the collector game object here. So whenever this collider, so previously we had a radius of 1.6, right? So when this radius touches anything, so over here, the code here, whenever the radius of the collector touches anything, it will check if that thing is a I collectible. So in our code, you will find in our pickup code, let me find the pickup code. The pickup code implements a interface called iCollectible. So an interface is basically like a way to identify certain objects. So if anything implements an interface, so the pickup here implements an iCollectible, right? So if you check if a pickup is iCollectible, it always returns true. Yes? So the code here basically checks if the game object we are colliding with is an iCollectible. If it is, then we will perform a certain set of actions. And what are these actions that we will perform? We will find the rigid body of that iCollectible object, and then we will apply a force that pushes it towards the player character. So we calculate where the force is supposed to push the player towards, and then we add the force to push the player towards sorry, what am I saying here? So the force direction over here. Okay, let me reiterate this one. So the force direction over here, what it does is that we are trying to find which direction the gem should be pushed so that it moves towards the player. So to do so, we take because over here this is the player collector script, right? So transform.position will give us the position of the player, and then collider.transform.position gives us the position of the gem. So by taking the position of the player minus the position of the gem, we will get a vector that points from the gem to the player. And then we normalize it so that we get a length of 1, and then we can multiply this vector by any scalar value, meaning any number, to manipulate how fast the force will be, how much force there will be. And then once we get the direction, we just multiply the direction by the speed, and we apply it as a force to the gem. And then this will move the gem towards the player. So later on, when we make a video of this, we'll add a link to an article that you can refer to if you want to learn more about vector math. So I don't want to go too deep into the vector math over here because this will be a whole other topic, right? And it'll probably get me to spend another 15-30 minutes. That's why I've done an article on this instead of having to repeat myself, because we've gone through vector math quite a few times in part 15 and part 16 already, so I don't want to keep reiterating. Alright, so article will be in the link below or to the top right corner of the video later on when we create the part 17 video. So once we apply the force, then we will call collect. And what collect does is basically it will apply the effect of the item onto the player. So you notice that the moment the player collector touches the item, the collect function will fire. So that's why the moment you touch a gem, the gem will apply its experience to you even before the gem touches you. And that is the problem that we want to solve. One of the problems we want to solve. And the other problem, of course, is this issue over here, right? So the gem just straight out misses the character. So why the gem misses the character is because the application of force only applies once. So what we want to do instead is we want to make it so that the gem constantly updates itself, because over here the force direction here is fixed. So once I apply the force on frame 1, if my character moves on an angle that is perpendicular or perpendicular-ish to the gem will just outright miss the player. So to prevent that from happening, we will have to make it so that the direction that the gem moves in will be updated every frame, instead of updating just one frame, which is the frame where the collector touches the gem. Right, because we only apply the force in one frame, this causes the problems that we have in terms of the gem not tracking the player properly. So what we're gonna do with this problem is that instead of having the collector handle the movement of the gem, if you look at the collector script, which is hidden somewhere inside my very large Visual Studio list of files. Okay, right here. Okay, if you look at the collector script over here, the collector script is the one that handles the movement of the gem. Okay, which is why there is a problem, because it only applies the force to the gem for one single frame. So if we want to let the player, if we want to have every gem update its direction in the the direction that it moves in every frame, we will have to apply the code over here and update, and it becomes very complex. If you want to see my initial attempt at getting the player collector to update the direction of the gems in every frame, you can check out the topic that is linked right here. The attempt wasn't very successful, but I've had a couple of scripts over here where I try and implement the gem movement under the update function instead of inside the onTrigger enter to the function. Yeah. So what we're gonna do instead of implementing everything in the player collector script is that we are gonna revamp the pickup script instead, so that the pickup script handles the movement of our gems. So how that works out will be as follows. So if you go to section 2 of the article, right, here is what we changed to the pickup script. Okay, so let me just go through the changes right here first. First thing I'm going to do is I'm going to remove the interface that we implement, the iCollectible interface. We don't need it. I'll explain why in a bit. Okay, so we'll remove the iCollectible interface, and then we'll remove the has been collected variable as well. So what has been collected used to do is that it used to let us make it so that if we touch the gem multiple times, right, when it's traveling towards the player, it doesn't apply its effect multiple times, because it's possible while the gem is traveling for our collector to collide with it, leave, and then collide with it again. So then this has been collected. If it's true, then when you recollect an item, you don't get the same benefits for the second time and on. So instead of these two, okay, we're going to add a couple of new variables over here. The first variable we'll add is lifespan, which is basically a limit to how long the gem can exist, or how long the pickup can exist after it's been collected. So when we collect the pickup is going to fly towards the player. But let's say if the player moves too fast, or some other reason. So mostly because if the player is moving too fast, the gem will never reach the player. So if the gem never reaches the player, then it becomes a problem, right? Or maybe there's some other bug that causes the gem to just fly off the screen. To make this flying off less apparent, we set a limit to how long the pickup can exist after it's been collected. So this lifespan here is meant to represent how long the pickup is able to exist when it starts flying towards the player. So if you keep avoiding the gem anyway, it will still disappear, and then it will apply its effect to the player regardless. Okay, so this is lifespan, and then we have two protected variables over here. One of them is target. This is who the gem is flying towards. So we are changing the way that target is applied as well. Previously, if I'm not wrong, we used find object of type. Now instead of doing that, we will be applying the target by using the collect function, but we'll get there later. So by having a player stats target over here, we are recoding the system so that in the future, if we want to implement multiplayer features, let's say we have more than one player stats object, because we have more than one player, then we can still, pickups can still behave as per normal if you have more than one player. So this is what we want to do for the future. So this is just the target that has collected the pickup, and this is the speed at which the pickup travels. We make it protected because in the player collector script there is a pull speed over here. So we just want to apply this pull speed over to the speed property over to the pickup later. So under update, this is where the magic happens. This is the main gist of our pickup script. We want so that whenever a target has been assigned, so if a pickup has not been collected, the target will be empty. So once we collect the pickup and target becomes populated, we want the pickup to constantly be moving towards the target until it's more than the lifespan. So for example, if the pickup is moving more than 0.5 seconds, it will destroy itself. Otherwise, if it touches the target, it will destroy itself as well. And because we're already measuring distance, right? If you look at this logic over here, what it does basically is that we're just getting the distance between the player and the pickup. Right? This is basically the pickup's, sorry, this is the player's position, and this is the pickup's position, because we are going from the perspective of the pickup now. So transform the position is the pickup's position. So every time we update the frame, we want to check whether my position and my target's position, how far are we? So if we are above a certain distance, then we will continue moving by setting the position of the pickup to be moving towards the distance between us and the object. So what this vector tool does is that this vector tool actually does two things for us. One thing is it helps us measure the distance, but also recall that because we take the target's position minus our own, we will get a vector that goes from us to our target. Again, the target is the player, so we want a vector that points from us towards the player. So here we get to measure the distance. If we grab the vector and we do a square magnitude, we get the square of the distance. And then here we basically can use this same vector, normalize it, and then we can multiply by speed and time at other time to get a vector and apply it to the position to offset the object a little bit for one frame. Yeah, so this moves the gem a little bit towards our target, and we only do the movement if we are still a certain distance away. And how do we measure this distance over here is to get distance as a value, we need to convert the vector into a length, right? So then that would be distance dot magnitude. But over here, why are we using distance dot square magnitude? This is because every time we use distance dot magnitude, we have to do a square root. So I think there's an explanation down here, right here. Okay, so for us to be able to measure the length of a vector, we will have to take x squared plus y squared and we have to square root it. So this square root is expensive. So if instead we were to use square magnitude, this will just be equals to, for 2D vector, it will just be x squared plus y squared, and for 3D vector, it will be x squared plus y squared plus z squared. So regardless of whether you are doing a 2D game or a 3D game, whenever you use a distance dot square magnitude instead of distance dot magnitude, or whatever your vector is dot square magnitude over a dot magnitude command, this is just a property, but in Unity, whenever you retrieve a magnitude property, there's a square root involved, right? So if you use square magnitude, you save the square root, you avoid using the square root, and this helps you to save some computational power, especially since we are doing this every frame. So by using square magnitude instead of magnitude, we can save quite a bit of computing power for our code. So when we use square magnitude, we will also naturally have to take the square of the speed that we have. Yeah, so here this will be speed times time dot delta time instead of the usual speed times time dot delta time. So by comparing our magnitude with the speed, we are checking whether, what we are checking essentially is this. So every frame, right, you will see that our gem, let me try and draw a proper gem over here. Our gem will move a little bit towards the player, which is like this. So our gem will move a bit towards the player. So you can think of maybe every frame, it will move a little bit, a little bit, a little bit. So the distance here is always more or less fixed. So once the amount of movement that we are going to be doing is less than the distance that we already have between the gem and the player. So for example, once the gem gets here, the next frame it will reach the player, right? So the gem, if it's here, it's going to be something like this. So once the gem reaches one frame away from the player, we will take it that the gem has been collected, and then we will destroy the object right here. That is essentially what this code is doing. So by measuring the distance directly, we also go around the need for us to use colliders, which are more expensive, especially box colliders. Not very expensive, but still is more expensive than us just checking distance, right? Checking distance is always going to be the fastest. So by doing this, we circumvent the collision detection system and we make the collection system more efficient as a result as well. So this update function basically fires, it starts running once we assign a target to the pickup. And when do we assign a target to pickup? Whenever we call the collect function. So we are changing the collect function as well in a couple of ways. Number one is we are adding a couple of parameters to the collect function. Over here we have player stats target. This is basically whenever we collect something, the item is collected, then we will assign a target to the item by this parameter. And then we also specify how fast we want the item to fly towards the target. And then the lifespan over here is custom. If we leave it at 0, then we will take the default value of 0.5. This is an optional argument. So what happens here is that later on you will see in the player collector script, we'll just call collect and then we will specify the player stats and then we'll specify how fast to move the item towards the player. And then we call this function and then this will cause us to assign target and speed. So once we assign target, as usual, this will cause update to start working, right? Because this part only works when we have a target. So if we don't already have a target, then we will assign a target, we'll assign the speed. We might assign the lifespan if the lifespan is more than 0. And then we'll set the game object to destroy itself once the lifespan expires. So what is this Mathf.Max 0.01f over here? This basically restricts us so that we cannot specify a negative lifespan. So for example, if this lifespan over here, if we specify this to be if we specify this to be minus 0.05 or minus 0.5, minus 1, whatever, right? This value will take precedence instead because this is the larger of the two values. So if I were to specify a legitimate lifespan, for example, 1 second, then this will be larger, so then this number will be bigger. So this basically takes the maximum of both numbers. And by specifying a low number as a maximum, we are preventing the lifespan from being able to go to 0 or below 0. So we basically mark the object to destroy itself, and then we assign 3 variables to the object. So why do we have these 3 variables over here? Or rather, why do we have this keyword in front of our variables? This is because we have 3 parameters over here that share the same names as lifespan, target, and speed. So by using the this keyword in front, we are essentially specifying that we want to manipulate the class variable over here as opposed to manipulating the parameter over here. So the raw target over here refers to the parameter, whereas this target refers to the target property inside the pickup class. Same with the speed and the lifespan attributes. So basically what we are doing is we're recoding pickup so that we use update and collect to power it instead of using onTrigger enter 2D. So in onTrigger enter 2D, you will see that previously this function was there so that when the pickup touches the player character, it will destroy itself. But right now, because we are recoding it so that it destroys itself after a certain time, or after it touches the player character, we do not need to have the onTrigger enter 2D function over here anymore. So this summarizes our changes for the pickup script, but because the pickup script affects other scripts that we have in our project, we will have to make a couple of other changes to our project before the whole thing starts working. So let me just copy the pickup script after I've explained everything. Right? Let me just copy this and then let me just paste it over here. So you'll need to apply the changes to your pickup script for part 17, and after that you will also have to remove the interfaces folder because this only contains the I collectible, right? Okay, I'll explain why this is not needed anymore. Let me just delete this first. And once you make your change to the pickup script, you will find other errors will occur. This is because we have to change a couple of other scripts as well before we can get our pickup system to work, because we are changing the way that the pickup collection works, right? So this affects our player collector script as well, and also affects our ExperienceGem script as well as our HealthPotion script, which I will touch on later on. Let me explain why we remove the interface over here first. So the reason we remove the interface is because this interface over here, right, what an interface is supposed to do is, generally an interface is supposed to help us to unify 2 different hierarchies so that we can use them collectively in an array or something. So over here, interfaces usually define a set of abstract functions. And then these abstract functions are supposed to be shared by two different hierarchies. One example would be, let's say if you have a game, and in your game maybe you have units. Units are basically moving objects that can be damaged, that can do damage, right? So for example, you have soldiers, you have player characters, you have maybe wild beasts, let's say in your game, Metroidvania, let's say. Okay, so you have different classes of enemies that can, or different classes of characters that can move around and stuff, right? Let's call them units as a collective. So you have units in your game, which are basically moving agents that can do damage and receive damage and move around. And then you may also have things like, say, barrels, crates, benches, destructibles, right? Destructible objects in our game. So these two classes of objects will belong to different hierarchies, right? So in such a case, maybe let me just draw a diagram to illustrate this. So let's say we have over here, let's say we have two classes, units. Okay, units will be things like soldiers, enemies, even NPCs, right? NPCs that can maybe cast spells or whatever, or just attack animals. Okay, these will be units. Okay, they're considered units because they have health, movement speed, right? And then we may have another class of objects called destructibles. And destructibles will be things that are non-moving. Usually, anything that doesn't have agency, right? That cannot decide where they want to go, what they want to do. These will be destructibles, just there for you to destroy. Right? So these two classes of objects. Okay. And under destructibles, you may have things like, say, benches, crates, barrels, trees, maybe. Okay. So because these two are of different hierarchies, we will not be able to perform an action uniformly for the both of them. So we cannot manage both. So for example, right now, if we have a spell that can do damage, and we want the spell to be able to do damage to both units as well as destructibles. How do we do that? We cannot do that. So we will have to perform a function to get all the units in the area of effect of the spell, and then we have to perform another function to get all destructibles within the area of effect of the spell. So this will be two function calls, all right, because we will have to find all units and find all destructibles, which is a little bit inefficient, right? So one thing that we can do is when we have different hierarchies of objects, we can unify these two hierarchies using an interface. So for example, I can have I damageable. All right, and this interface will be implemented by both units and destructibles. So interfaces, you can, if you go online, you will find a lot of videos that explain interfaces like their contracts. In a way, this is correct, but this doesn't really illustrate why we use interfaces. It took me a couple of years to understand how interfaces are used. But basically, whenever I have I damageable, what I can have in my damageable interface is I might have a contract so that anytime I have something that implements damageable, it must have a damage function. That's it. Okay, so because units implements I damageable, and because destructibles implement damageable as well, I damageable as well, they both have to have a damage function. So this is what interfaces are for. By implementing I damageable, right now instead of calling a function to find all units and to find all destructibles, I can just find all damageable objects. Okay, let me show you what I mean, right? So without the interface, you would have to call something like this. You would have to do this. Okay, so for example, units, array of units, all units, all right? Then you may have to do a find objects of type, and then units. So by doing this, you can find all the units, right? So let's say I want to cast a spell that affects everything globally, right? So previously, I would have to do this, and then I would have to find all the destructibles as well. And I'll do the same thing, right? But except this time, this will be destructible. So this is what I would have to do. I would have to call find object of type twice if I didn't have interfaces. But with interfaces, I can just do this. Let me just move this down here, right? We'll just get more space here. Text here. So with interfaces now, I can just do this, all right? So I can just I damageable, all damageable. Find objects of type I can begin. So by doing this, you see this saves the amount of code I have to run, because right now I only have to run one line of code as opposed to running two. Yeah. So this is what interfaces are used for, to unify multiple branches of different objects under the same umbrella, okay, in a sense. So because over here we are not unifying anything, so the iCollectible interface right now doesn't really do anything for us, which is why I'm removing the iCollectible interface. So we remove the iCollectible interface and we update the pickup script, and then we should, well, our code still can't do anything, alright? So the next thing we have to move on to is we'll have to also change our player collectible script so that it reflects, or rather because our player collector script, right, because it calls the collect function. So we have to change the way the collect function is used in our player collector script before our system starts to work properly. So yes, let's go and change that. Okay, let me just have some tea, right? I bought my tea and I haven't drank it yet. It's getting cold. So hi Chiu Tian. So if you have any I don't quite understand what you're trying to ask, but let me know in the chat. So you try to apply the enemy movement script to replace the movement and then add the on destroy function. Yeah, sorry, I don't quite get what you're trying to say here. Okay, I'm gonna continue explaining it. Just feel free to leave your message in the chat, and I'll answer them as far as I'm able to. Okay, so the next part of this is for us to update the player collector script. It's right here. Okay, let me add a heading to the script so I can copy it. By the way, happy Chinese New Year. Xiu Tian, I'm sure you are Chinese, right? So I hope you've gotten lots of red packets that you can use to fund your hobbies or to buy new games. Okay. Let me just update the article and we can move on. Okay, so the next thing here is updating the player collector script, right? I should update this part as well, right? It's looking wacky. The formula is looking very wacky over here. What's going on? Formula is all messed up. Wonder why. Okay, there we go. Now the math is displaying properly. Okay, let's move on to the player collector script now. Why is this not showing? Where is my player collector script? Okay, I put it in the wrong place. It should be down, 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 all the way down here. Okay, there we go. Okay, so what's going on with the player collector script? So recall that we changed the collect function over here. So because we've changed the collect function, we will have to update our player collector script. to use the collect function as well. And here we go. So the first thing that we change in the PlayerCollector script is as follows. Okay, so we add a RequireComponent type of circle collider. Why is this? This is just a small quality of life change to reduce the number of bugs that you will have. So by adding this highlighted portion over here, we are mandating that when you use the PlayerCollector component, you will always have to use it together with a with a circle collider. So if you look at my collector object over here, the PlayerCollector will always have to have a circle collider. I cannot remove this. My bad, because I haven't added this thing yet. Okay, let me just show this to you. If I was to add this RequireComponent directive over here, this is called a directive. So what I'm saying over here is that I always have to have a circle collider that goes together with the PlayerCollector. I cannot remove the circle collider. Okay, I can't show you now because my script's not compiling. So because my scripts are not compiling, they're not updating. But once my script compiles properly and I add this directive, I will not be able to remove circle collider. And if I was to add a PlayerCollector, the circle collider will automatically be added as well. Okay, again, I'll show this to you later. So there are a couple of things you can do with this directive. Besides just adding a specific component, you can also apply a general component. So for example, if I was to say RequireComponent type of collider 2D, this means that my PlayerCollector will have to have some kind of collider. Doesn't matter what collider. It can be a box collider, polygon collider, can be a circle collider as well, or can be an edge collider. Anything that has a collider 2D at the back of its name will suffice. So depending on whether you want a specific type of collider or whether you want just a generic 2D collider, you can apply the corresponding directive, and this will cause your component to always require that particular component. So it's just a quality of life change that helps you to reduce the number of bugs that you have, right? Because if it forces you to have a collider, then you will never forget that you need to add a circle collider to the PlayerCollector component. So the other thing is that this is again this is more of an aesthetic change. I want to call this detector. I don't want to call this the PlayerCollector. It's just lesser things to spell, lesser characters to type. That's about it. Okay, so what our PlayerCollector is going to be responsible for is just going to be responsible for detecting whenever something is within its radius. And once something touches the PlayerCollector, it will just call the collect function on the pickup. So in the start function, I'm removing us trying to find the player stats or the circle collider. Okay, so the circle collider over here, we are going to deal with the circle collider later. So what we want to do in the start function over here is just get the component in parent. So this is a change from us using find object of type. So what find object of type does is that it finds the entire scene to locate the player stats component. Instead of doing that, because our player stats is going to be one game object higher, right? This is a child, this is a parent. So we want to find the player stats component in the parent, and then we will use that player stats. So why do we do this instead of doing this? If we were to use find object of type, we will always find the same player stats. So if we are gonna make this game multiplayer in the future, if we were to use find object of type, then this would just cause the game to not work because it always returns the same player stats. So by doing get component and parent player stats instead, we will find different player stats depending on, say, player 1 will have its own player stats, player 2 have its own player stats, right? So get component and parent will get the corresponding player stats for player 1 and player 2, which means that it's multiplayer compatible, as opposed to find object of type, which will not be multiplayer compatible. So this is just, to optimize, to improve our code, so that in the future we will have more ease when it comes to coding multiplayer functionalities for our game. Okay, the PlayerCollector object over here we're removing because we renamed the PlayerCollector to detector, and also because we are populating this variable later on in another function. Okay, so the other inefficiency I found in PlayerCollector is that we're updating the radius of the PlayerCollector every frame, which is not necessary, right? Especially since you're updating a collider, and the collider affects Unity's physics system. I don't like to update colliders in real time every frame because it can get very expensive to do that. So I'm going to remove the update function. Okay, what's going to happen instead is that the collider is going to be updated inside this function called setRadius. It's a public function. So this means that whenever we want to update the collector, we just call setRadius. Okay, and over here I'm just checking if there is a detector. So if we haven't found our detector, which is previously named PlayerCollector, right? It's just a Collider 2D. So if we do not have a Circle Collider 2D that's found here, we will just get a component. Again, this is the Collider 2D that accompanies the PlayerCollector. So the first time we call setRadius, we will find the Circle Collider. And then why do we want to do that? We want to do that because we want to apply the radius error to whatever the detector's radius is. So basically we are just moving the work from update, which runs every frame, to setRadius. So whenever our stats update, our player stats component is just going to call setRadius over here, and then this will update the radius of our Circle Collider. Okay, and then under on trigger enter 2D, it's much the same, except that because we are no longer applying the force using the PlayerCollector, we are just removing all the codes that applies forces to our pickup. Instead, we are just going to call pickup.collect. Okay, and then we're just modifying our target component over here so that it doesn't use an iCollectible, instead it uses pickup. So the pickup here, we name it P so that there's just less of a, we just have to spell lesser number of things, right? Lesser number of characters, shorter spelling, easier to type. Yeah, so we are changing this from iCollectible to pickup P. And then over here, we remove the game object over here is because Collider, we can do a Collider.TryGet component. This is the same as adding the game object. So colliders have a shorthand that allows you to use TryGet component. This will anyway try to find a pickup component on the same object. Okay, so this is just a long way of writing our code. So then we are just, all in all, what we are doing for on trigger enter 2D is it's the same logic, except that we are removing the physics, and then we're just going to call collect on our pickup. Again, the reason for that is because our pickup, we have recoded it so that the pickup object handles its own movement, right? So we no longer have to handle the movement inside the PlayerCollector script. So this actually shortens our PlayerCollector script by a fair bit. Okay, previously it was pretty long because of all the logical bit. Okay, and because our interface has been deleted, the old code no longer works, right? So let's replace that with the new code. And I'm just going to cover up some space in my code as well. Okay, so the new code is going to be relatively shorter. Okay, quite a bit shorter. Okay, if you try and save this, you will find your code still doesn't compile. Okay, so there are couple more things that we need to address before we can get our system to work. First thing is that this setRadius over here, we've got to address. Why do we have to address this? Because previously it was updated every frame. So now because it is not updated every frame, we have to trigger the setRadius call whenever our player stats are updated. Okay, so where do we check when our player stats are updated? This is under our player stats component. Alright, so let's scroll all the way down. Player stats. Okay, so in player stats, if you recall, right, we have a recalculate stats function somewhere inside. Okay, so it's all the way here. Recalculate stats. We'll find it. Okay, where is that? Just give me a moment to find this. Okay, so under recalculate stats here. Okay, if you recall from part 15, when does recalculate stats fire? It fires whenever we receive a new passive item, because this will change our stats, right? So then whenever our stats are changed, we will just call collector.setRadius to update the stats. Okay, so this means that we will no longer have to update our collector's radius every frame, which again optimizes our system. So on top of our code, we are just declaring a new collector variable, because for us to update the collector's radius, we also have to get access to the collector object, right? So over here in the collector, because the collector object is always going to be a child of our player, the player stats is right here, and then the collector is right here, right? So then because of that, for us to find the collector object, we're just going to find all our children and then find the corresponding player collector script. Okay, so that's why we do a get component and children here. And then the first time that we get the collector, we will just assign a radius to it. Okay, this is because recalculate stats only occurs when we level up or when we collect an item. So then we want, so that when the game first starts, we also want the collector to have a radius. This is why once we get a collector, we are applying the collectors. We are applying our magnet stat to the collector's radius to update it, because by default our radius of the collector is 0.5 is the default size of the collider, right? So by default the collector's radius is not updated, which is why we've got to update it. And that's really about it. So it's just a couple of lines of code, okay, to populate the variable and to set the radius. Okay, so over here, this, calculate stats, and then this is the awake function, right? So for this, I can just type it out actually. So let me just write it out over here under player stats. Okay, so we just add a collector variable. So where did I add it? I think it was above awake, right? Okay, so player collector, and under inventory here, I'm just doing collector equals to get component and children, player collector. And finally, once we update the base stats, then we do collector set radius, then we pass the magnet stat. So this is actual stats, and then this sets the collector's radius, and every time the stats are recalculated, we do the same thing. Collector set radius, actual stats. So this fixes everything for the player stats side, and I think we should be almost done. This is a pretty short part, surprisingly. Okay, so once we are done with this, if we go back to the project, there are still two more errors that we find here. And this is because for both our ExperienceGem and our HealthPotion scripts, they have subclasses. So you see ExperienceGem actually subclasses pick up. So does the HealthPotion. So we just have to account for these two classes as well to be able to get our code to work. Okay, Chu now I'll need you to, so I'm reading a chat now. So I'll need you to head over to the forums and post a screenshot of your error, because I'm not very sure which error it is. So post a screenshot, and then the error should reference the script as well. You can make a post of the script, and after the stream, I'll have a look at your issue and respond to you. I'm not sure if you missed one part or whether it's just a project specific error that you have. Okay, so next up, now that player stats is modified, next thing I want to do is, okay, so after we fix the player stats, right, we are going to have to account for the changes because ExperienceGem and HealthPotion both extend pickup. So we will have to either modify these two classes so that the collect function is updated, in which case we have to do something like this. So if you look at the pickup class, right, pickup class is collect function, so it has all these arguments. So you either have to modify these two classes so that it uses the same set of arguments as well, like this, and returns the same value. So either we do this, or I bet this is the wrong place. So either we fix our function somehow. Okay, this is one way to fix it. Either we fix the function somehow, or we just remove these classes. Okay, so Okay, this shouldn't be super, this should be base. Coding too much Java. Okay, so either we account for these in our ExperienceGem and HealthPotion scripts, or we delete them. So what do these two classes do, or what did they used to do, is they used to, so the ExperienceGem increases the experience, right? So what it does is the ExperienceGem script actually just has an experience granted variable, and then basically once the item is picked up, it just applies an increase in experience to the player. And for the health potion, it's a similar thing. Where's the health potion? Health potion is right here, right? So the health potion does the same thing, it just increases the player's health. Okay, so now that we've changed the pickup script, we have to update the classes. Okay, but instead of doing that, I'm just going to delete the health potion and the experience gem. So because they both perform pretty similar functionality, I'm just going to merge their functionalities into the pickup script. Reason for that is because just to have a subclass to increase experience or to increase health, I think it's unnecessary. Okay, so the pickup can handle these two things. Okay, again, these are very basic functionalities, right? So we are gonna just merge everything to the pickup script. So we will just add a bonuses header over here, and then from here, we will just add an on destroy, and then inside the on destroy here, we will check whether, or rather, we will just increase the experience and increase the health by the corresponding amount. So what this does is that this will have it so that we don't need the pickup, so we don't need the experience gem as well as the health potion scripts anymore. So let's go back to the pickup scripts, and then let's add a header, and this will be bonuses, and here we have public float experience. Are they floats or are they integers? Double check. Okay, they're integers, so public integer experience, and then public integer, and then we will add an on destroy function. So why do we add an on destroy function over here? This is because, if I'm not wrong, I made this virtual as well, right? So this will be protected virtual void on destroy. And then if there's no target, then we return. Okay, so first, okay, what is this if no target then return? Okay, as the gem flies towards our target, it's possible that the character dies. So if the character dies, then the gem or the health potion will have nothing to apply the bonus to. Alright, so when it destroys itself, if there's no target and we still try and increase the experience of a target that doesn't exist, or try to increase the health of a target that doesn't exist, it will give us null reference exception. So by adding this extra line over here, this prevents the null reference exception from occurring, because it just means if there's no target, do not apply any bonuses. Okay, then we just do target increase experience, then we do target increase extra health, right? And health. So what it does is that it just applies any experience bonuses and any health bonuses you can. Okay, so yeah, that's about it. I think we can also apply a check so that if experience is not equal to 0, we only apply the bonuses if the bonus is not equal to 0. Okay, so this is just some extra lines. Let me just update the article as well, and I'll explain why these changes are made later. Okay, so why do we check experience not equals to 0 with health not equals to 0? Okay, so take note that for those of you who are using floats instead of integers for experience and health, instead of using the not equals to sign here, you have to use Mathf.Approximately. Okay, if you're using decimal numbers, you will have to use approximately instead of using the equals to sign. The reason for this is because if you use floats, right, and then you compare them directly with equals to, you will never get the condition to be correct, because floats have different amounts of precisions, and if you do not use approximately, it means the numbers have to be exactly the same, which is very hard for floats to do. So again, if you're using floats, you've got to use approximately to compare your numbers. All right, do not use the equal sign. Okay, this will cause your code to never trigger. Okay, so here we are saying that if the number is not approximately equals to 0. Okay, if you're using float. Okay, for me, because I'm using integers, so I'm gonna be doing this instead. All right. So integers, you can always compare that directly using the equals to sign. Okay, so it's up to you whether you want to use floats or integers to compare. Okay, so why do we have to check whether it's not equals to 0? So in the future, right, what we may do is that, okay, so if you play, for example, Dota, or if you play, say, League of Legends or whatever, right, in games that are relatively complex, there may be effects where, for example, let's say there may be heroes who have abilities that boost your healing. Okay, so let's say if your healing is boosted, right? So let's say when I restore health, maybe I have an ability that makes it so that every time I heal, I will get a +5 to the healing. So then every time I pick up an item, if the healing is 0, whenever I call restore health, right, the ability may trigger. This is if we call abilities, special abilities in the future, that maybe trigger when our health is restored. We do not want the triggering of the restore health to happen when we restore 0 health. Whenever we pick up, let's say we pick up an experience gem, because now we combine both the experience and the health potion together, right? So whenever I pick up an experience gem, I'll restore 0 health. Okay? So when I restore 0 health, I do not want any special abilities to trigger. Okay, if we call abilities in the future. Okay? So this is why we do not want to call restore health when our health restored is 0. Okay, in the future, if we were to add passive abilities or whatever, it will be applied through restore health. Because over here, we can detect whenever a player restores their health. Yeah? I hope this makes sense. Okay, so yeah, so once we apply these changes to our pickup is able to award experience and award health. So the next thing you want to do is to remove the experience gem and remove the health potion. And then from here, you will see when we remove those, we have to go to our prefabs, go to our pickup, and then over here, we have to retool our scripts to, oh, sorry, before that, okay, one more thing, all right? So inside our part 17 code, okay, you will find also that we are reformatting the bobbing animation. So you will see there's a bobbing animation component on our scripts as well. Sorry, in our prefabs as well. And this basically gives the item the animation that moves up and down. Let me just show this to you. Okay, so this makes our item just bob around like that. Okay, so we are going to merge the bobbing animation component into the pickup script as well. The reason for that is because the bobbing animation script, right? Let me just open this up. Bobbing animation, where is it? Okay, bobbing animation. Okay, so the bobbing animation, anyway, this is reliant on the pickup component. Okay, so because of that, the idea behind splitting the bobbing animation script with the pickup script was so that the bobbing animation can be applied to other components as well. But because over here, the way that the bobbing animation was coded is so that it relies on the pickup script anyway. Okay, so this makes more sense for us to just combine the two scripts together. So initially, I was thinking about whether I wanted to merge this in the pickup because I didn't know if it was possible for us to use this script for other purposes as well. But because after looking through the script, I realized that there was no way for us to use the script for other purposes. So I thought might as well just merge this in the pickup script. Okay, then we will save doing get component. Okay, so one other thing that you will find when working in Unity is that if you have too many components, right, it will slow the performance of your game down. So if you were to merge separate components that anyway I rely on one another, this will speed up your game, because now instead of working over two components, it's just going to be working within one single component. Okay, which in terms of data retrieval, this will make Unity work faster. So what we're going to do is if you look at the article over here, okay, Again, we highlight over here the changes that I made. So we are just transferring all the variables over from the bobbing animation script over to the pickup script. So we will store all the data. So in bobbing animation, there are three levels of data, or rather three different variables. I don't know what I'm talking about. Three different variables, four different variables actually, that manage the animation of that manages the animation. Okay, one is the frequency, which is how fast the animation repeats itself. Magnitude is how much the bobbing animation moves. And then we have direction as well, okay, which is basically where the bobbing happens. So whether it's moving up and down or left and right or anywhere in between. So I'm going to be merging direction and magnitude together because the vectors themselves already store magnitude as well. Okay, because you can control how long or how short the vector is, right? So we're going to remove this, and then we're just going to store these two values inside our bobbing animation. Okay, so we are creating a struct that is nested inside pickup that will store the frequency and the direction of the animation. I will make it serializable so that we can display this in the inspector. So if I was to copy and paste this into my pickup script, okay, I'm just gonna copy and paste everything in first, and later I'll show you what the variables do. So this goes above bonuses. Doesn't matter whether you put it above bonuses or before. For me, it's just an organizational thing. Okay, and then under here, so what happens with our pickup is that before it gets collected, it's gonna be bobbing, right? So if you look at the code over here, the target over here, this is after collection. So very naturally, the code for our bobbing animation actually goes into the else bracket here. It's quite a natural thing to put it inside here. So we're just gonna put the logic for our bobbing animation, which is right here, right? We can just grab the formula over here and just drop it inside the else portion. Okay, we'll replace this magnitude because it's no longer there. This will be bobbing animation frequency, and this will be bobbing animation in that direction. So again, this is declared over here. This is a variable that we declare that allows us to control how the bobbing works. Okay, and this struct allows us to, okay, I'll explain this thing later on when I show you the inspector, right? And then we also have to save the initial position. So we have to have a start function right here. Okay, the start function over here basically helps us to save the initial position of the pickup so that we can move it, but always move it around the initial position. So we don't want the item to move out of the way. So the initial position is, okay, I'm sure in the earlier part Xavier explained this, so I don't know why I'm explaining this all over again. Okay, later on when we're editing, we can leave this portion up. Okay, anyway, the formula is explained, so we just have to move the code over to the pickup script. Okay, we don't have to re-explain all the formulas. So by applying these changes to the pickup script, we can now delete the bobbing animation component, the script, sorry. And then if we go back to our pickup prefabs, which are right here. If you go back to our pickup prefabs, sorry, it's under here. Okay, so if we have to open the prefabs and we have to remove our old scripts. Okay, so all the codes should be fixed. So we just gotta remove our old scripts, the bobbing animation and the HealthPotion script, and then in this place we'll put the pickup component, and then here we just set how much health we restore. So let's say it's 50. Bobbing animation already has some default values over here. Okay, so how do we set up the bobbing animation so it has a drop down over here? This is because we've added a struct right here, and then we made it serializable. Okay, so after that we declare a new variable of the type bobbing animation. And then whenever we declare a struct, okay, we can use curly braces over here to set default values for them. Okay, if we leave this out, we can totally leave this out. Okay, but if we leave this out, then when we add a new pickup component, the values will be 0 by default, which is not something that we want. Okay, so let's say changes, store apply. Okay, let's see if this recompiles. hasn't the bobbing animation script been deleted? Why the errors still show? So let me remove this again. Okay, so if what I was saying before was if we were to leave the default values here, so there were default values that we were setting here, right? Let me just grab this from the article again. There were default values that we were setting from here. Okay, so if we were to set default values over here, then when we add the pickup component, then there will be default values in the bobbing animation. Okay, if we were to remove these values, then when we add a new pickup component, you just remove them and then re-add them, right? So if we add a new pickup component over here, then there'll be no default values. So because we want it so that when we add a pickup script, there'll be a default bobbing animation. This makes level design job easier, right? So by doing this, it'll be easier for us to make our prefabs, because now automatically default values will be set. Frequency of 2 and a direction of 0 and 0.3, which is pointing up. Alright, so with default values over here, it's a lot easier for us to set our pickup component. Yeah, so we just gotta set the health in this case. Okay, so then same thing for the experience gem. We will now have to update the experience gem with the new components that we've created. So again, we remove the old component for the experience gem and then the old component for the bobbing animation, and we just add the new pickup component over here, and then we can set the amount of experience that it runs, and now the whole thing should work pretty well. Okay, so now we have a gem that bobs, and then if we move close to it, okay, it still goes to me, but it kind of still reminds you of the old system. Okay, this is because we have to go back to our collector component as well and reduce the pull speed to a more reasonable amount of 10. Okay, and the whole thing should work properly now. Okay, so now you'll see the gem moves to us quite well. And if I were to move at an odd angle, right, it will follow me. Okay, it will follow me instead of flying off nowhere. Okay, so why do we have to reduce the pull speed from 200 to 10? Recall that previously we added a force. Does it make sense? So we added a force to the gem, and the gem itself has a mass, right? If you look at the gem has a rigid body, which means it has a mass. So whenever you have a mass, you add a force to a mass, then the force is F equals to ma, right? So the amount of acceleration that you give will be, okay, let me just draw out the formula over here. For those of you who are old enough to have learned physics, you will recall F is equals to ma, right? So F equals to ma, which means that if you wanted to get the acceleration is equals to F over m. So this means that the force that you apply will be divided by mass, which means it will be reduced. Okay, so because your force is reduced, you will have to apply a much larger force to be able to push the object at the same speed. So if you look at our code over here, we no longer are applying a force. We are moving the object directly. And because we are moving the object directly, we now have to lower the amount of the value that we apply, because it's no longer being divided by mass. Alright? So because it's no longer being divided by mass, it's no longer affected by drag forces and all that stuff. So the pull speed cannot be the original value, otherwise it'll be moving too fast. Okay, so we have to go to collector and then reduce the pull speed from 200 or whatever value that you have, just divide it by about 10 or 20 and you will get a more reasonable amount. Okay, so now we are just setting the speed of the object directly. Okay, so speed of 10 is relatively fast. If I was to remove this, you'll be able to see the tracking a lot better. Okay, so if I remove the pull speed to 2, you will see that the object now tracks you. Okay, and moves close to you and then it applies its effect after that. Okay, and again recall, because of the lifespan, we've set a lifespan for the object, right? So you will see if the object is still not touching the player after half a second, which is the lifespan over here, automatically it will just apply its effects to the player. So if I was to increase the lifespan, for example, to 5, you'll see the object becomes more patient. It will take 5 seconds to try and track the player before it applies its effect. Okay, so the lifespan allows us to control how long the object will try to track us. And that's about it. Okay, so the last thing that we want to change for pickup is that if we were to place multiple objects onto the scene, right? Okay, you will find that the animations are totally synchronized. Right here. Okay, so this is not very good. So one thing that we can do is we can also add a new initial offset. This will be a float initial offset, and this will just be a random value. Okay, so this random value over here is just going to be initial offset, and this will be, I forgot what the value is. Okay, and this will just be a random value between 0 and our frequency. So what we're doing here is we're getting random value here, and then we're just offsetting the time with the initial offset. So this is basically us changing the starting frame of our objects. So because if they all start in the same frame, right, then they will always be moving in the same position. So by adding a random initial offset over here, what I'm doing is I'm making it so that they will all start at different frames of the animation, so the item will not be totally synchronized. Okay. Zoom in here, you'll be able to see right now it's not as synchronized as before. And again, this is because we added an offset to the time component over here for the problem. So once we add that component, you see a more organic looking pickup, even if they spawn at the same time. This will be great for, let's say, when you have AoE weapons and then you destroy a large number of enemies, right? When that happens, then all the items will spawn at the same time and they will all be looking like this, which doesn't look good. But if you add a random offset, then they will all look a lot more organic, which is always better. Okay, so part number 6 we've just done. Okay, so once we've applied all our changes to the code, we will want to again reduce the pull speed, and then update your pickup prefabs to remove the old components for BobbingAnimation and ExperienceGem or HealthPotion. Okay, so this part here is surprisingly it's short. It's quite short, so I'm done with this part. So next thing we're going to do is we're going to be chopping up the video and then creating part 17. Okay, so once part 17 is done, the next part we will be, what we promised in part 16 was part 17 will be about implementing the rest of the stats, right? Okay, so I'll be spending the next couple of weeks doing some code with me streams, so where I'll be preparing the content for part 18. Once part 18 is done, I will do another stream just like this, a content creation stream, to create the content for part 18's video, and then we'll tie it up as usual. So this is pretty short stream, but thanks for joining us anyway. Okay, so let me just look at the chat to see if there are any questions before I go. Okay, so as usual, thanks to the Patreons, thanks to everyone who's watching our videos, supporting us, and coming to the forums, all that stuff. As usual, we really appreciate it. So I'll see you guys in the next video and the next stream, whichever comes first. Alright, so I'm gonna go celebrate my Chinese New Year again.